In this lesson, you have to integrate 1 plus x squared gx. Using the Euler's method, 1 plus x squared square root of this can be equal to what? X plus g. The next step, you are going to isolate the x by squaring both sides here and squaring here so as to isolate this x. We're going to be having 1 plus x squared is equal to what? X squared plus 2xg plus g squared. From here, x and x can cancel. We can bring out this 2xg. 2xg is equal to what? 1 minus g squared. From here, our x is equal to what? Our x is equal to 1 minus g squared all over 2g. That will be equal to 1 all over 2g minus g all over 2. Okay, to remove this gx here, we are going to differentiate this. Therefore, our gx is equal to what? Our gx is equal to 1 all over 2, 1 all over 2 g to the minus 1 minus 1. Okay, bringing this negative here, we just erase. Our gx is equal to what? Differentiating that is negative half g squared. Okay, by substituting. Okay, minus half. Bring the g on this other side. Okay, we are going then to substitute this in the initial equation that is integral of x squared plus 1 gx, that is the square root of this. Okay, and we are going to be having what? Integral of, we can just okay, we know that x squared plus 1 is equal to what? X plus g. Okay, we are going to move on and have x plus g times what? We substitute back our initial substitution, that is negative 1 over 2g, negative 1 all over 2g, all that square, minus half times g. I must have the g, sorry. Okay, this is what you're going to having integral of this. Okay, we have all in terms of g, but we have an x here. But we have to remove this x. How can we remove the x? From here, x is equal to what? This. Hence, we're going to substitute it back here. That will be integral of what? What is our x? 1 minus g squared all over 2g, okay, plus g, all that times what? Negative 1 all over 2g, all that square, minus half, all in the g. From here, you can do the LCM so as to have a uniform, all in uniform form. Okay, doing the LCM here, you are going to be having what? Integral of, you have 2g at the level of the denominator, you are going to have 1. You're going to have 1. Okay, when you are going to do the LCM, 2g, you're going to have 1 that, and here you are going to have 2g square. Negative g square minus 2 plus 2g square is equals to, will be plus g square on this side, and the other side you are going to be having what? You can bring out this negative since they are all negative. You put a negative here. You have what here at the denominator, you have 2g square. You're going to be having 1 plus g square. Okay, in the LCM, g. We proceed by having negative integral of 1 plus g square all over 2g times 1 plus g square all over 2g square dt. We can cross multiply. We can multiply these two to have what? Integral of 1 plus g square all that square all over, I love the denominator, we are going to have 4g cubed without forgetting our gt. Okay, we can expand this numerator to have what? Negative integral of, we expand, that is 1 plus 2g square plus g to the power 4 all over 4g cubed dt. That is what we're going to be having, g to the power 4 dt. That is equals, you can bring this 1/4, that is negative 1/4, since you have 1/4 in common, and divide all through by g cubed so as to easily integrate it. It's 1 over g cubed plus okay, chi square all over 2 plus chi all over. Oops, you are making a very big error at this point. I'll just erase. Therefore, you bring out 1/4, sorry, here we are going to have 2 into 1 all over chi plus chi. Okay, all that in the chi. Okay, that is what we're going to be having. Okay, proceeding with this. Okay, we are going to be integrating this. Let's just do it here at this point. Integrating this, we are going to be having what? We bring this up, we are going to be having chi to the power negative 3 plus 1, that is 1 over chi square with a 2 here. Integrating this, we are going to have 2 ln of chi, and integrating this, we are going to have chi square all in 2. Okay, therefore our answer next will be equals to what? We just recopy, that is equals to, just recopy, negative 1/4 in bracket, we are going to have what? 1 all over negative 2 chi square. Because here we are going to say negative, because when you are going to bring up, it's going to chi negative 3 plus 1, that is negative 2, and we bring it down. Okay, and have this negative 2 chi square plus 2 ln chi plus chi square all over 2. That is what we're going to be having. Okay, you can just omit the k at this point because it's going to be a bit longer. Okay, we earlier know that chi is equals to what? From here, we can find chi. From here, you can find chi. Chi is equals to, from this point, you can have chi is equals to what? Square root of x square plus 1 minus x. Okay, from here, since 1 plus x square is equals to, let's just erase and hide it. Can just do a general erasing here. We know that 1 plus x square square root is equals to what? X plus chi. Hence chi is equals to what? We bring this x here, that is minus x. Okay, we just have to substitute it here. Our chi is equals to what? Square root of x square plus 1 minus x. Don't get confused at this point. Okay, this is what we're going to be having. Therefore, we just expand this point. That is, we have 1 over 8 chi square, 1 over 8 chi square plus, yeah, we have a minus, that is minus half ln chi minus chi square all over 8. Okay, we can just combine the terms in 8 together to be having what that will be equals to 1 all over 8 into what? 1 all over chi square minus chi square. Okay, are you good? Okay, we combine this one and bring out the 8 minus half ln of chi. This is a very crucial point. Yeah, just think about it. Then going to substitute chi back to have in terms of x, because you have already integrated. We want to have in terms of x. Okay, therefore you're going to come back with this in terms of x. Let's just solve it. You just take first of all this part and then this part. Okay, so the part is just say another plate. Okay, using this one still, you're having 1 all over chi square minus chi square. Okay, I asked to bring this in terms of x, since chi is equals to square root of x square plus 1 minus x. Okay, we just substitute back. That will be what? You have chi square, that will be 1 all over x square plus 1 minus x. And just put all this square minus x square plus 1 minus x, okay, on square. From here, we're going to use a strategic method that is doing the conjugate of this. So as to remove this, in the conjugate, there is x square plus 1 plus x. And you're going to also multiply the denominator by that. Okay, don't forget the square root, sorry. There is a square root here. There is a square root of x square plus 1. With a square root here, because that will confuse us. and we multiply on the other side by the square root of x squared plus 1 plus x. Okay, we are going to end up having what? At the numerator, we are going to be having x squared plus 1 plus x square root of this, all this square. Okay, that's what we're going to have at the numerator. And at the level of the denominator, we have x squared plus 1 square root of that minus x. We multiply this by square root of x squared plus 1 plus in x. If you make this times this, we are going to have what? X squared plus 1, okay, minus x squared. This and this will cancel. We are going to be left with 1 at the denominator. And on this other side, we are going to be having that is square root of x squared plus 1 plus x, all this square. On the other side, that will be minus what? X squared plus 1, all that minus x, all this square. Okay, looking at this, we have a difference of 2 square. You can then expand this. You are going to do it by yourself. That is opening this bracket. Just take this as a and this as b. Then you are going to have a square plus 2ab plus b square minus, on the other side you take this as a and this as b, same the same thing. You're going to have what? Minus a square, okay, we have a minus, just be like this, minus 2ab plus b square. When you find yourself having at a point when open the bracket, let's just open the bracket imaginarily. You have a negative, you have a positive, you have a negative here. A square and a square will cancel out. Okay, that's a better method. B square and b square will cancel out. We are going to have what? 4ab. That is what you're going to have now. 4ab. 4ab, and this is what we have. 2 times 2. Okay, that is 4. 2 times 2. 2 times 2. This ab, that is 4ab. That will be equals to 4x squared plus 1 dot x. Yeah, that's what we're going to have. That will be equals to 4x times square root of x squared plus 1. I think this strategy is still better, because if you keep writing all this, you are going to waste a lot of time recopying and recopying. Better take this as a and just denote as b and do it easily, and that will be very, very clean. I appreciate this method. Okay, let's proceed. 4x times x squared plus 1. We substitute back this in our initial equation. Where is it? And this is it. You are going to have what? 1 over 8 times 4x square root of x squared plus 1. Okay, let's move to this other one, this other comrade. We just erase everything here. Just erase. You take the ln chi. Ln chi. You just take negative ln chi. Okay. Negative ln chi is equals to what? Ln of 1 on chi. Since that will be chi to the negative 1, and from the linearization, you can have 1 on chi. And this is equals to what? Ln of square root of x squared plus 1 plus x all over 1. Okay, some guy will just ask me, why are we doing it like this? Let's move to the next slide. We have chi is equals to what? Square root of x squared plus 1 minus x. Yeah, that is it. Therefore 1 all over chi is equals to 1 all over square root of x squared plus 1 minus x. At this point, you are going to do the conjugate of this. So have a square root of x squared plus 1 plus x. There is a conjugate, and you have the same thing down. And from earlier, we denoted that when you do a conjugate, you are going to be having 1 at the denominator and x squared plus that at the numerator. You're going to have this as the answer. Recopying it here, we are going to be having, since you have already removed the negative, that will be half. ln of x squared plus 1 plus x square root of this. And this is equals to what? This is equals to, okay, half. Where is half? I just bring out the half generally. Half x times square root of x squared plus 1, okay, plus ln square root of x squared plus 1 plus x plus a constant k. And you come to the end of this video. Just on this other video that will be talking about integration of sec square x, or this one under here, or this one at the left or at the right, just take choose one of them and watch. See you in the next video.